Greetings and welcome back to room 303 in sophomore English. We turn now in our hymnals to page 472, 473, the Dava Sobel text, Longitude. You'll see here that we're actually going to be reading from a text, Longitude. That's because this is a longer text and we're going to be looking at a small part of it. Hey, before we get to, though, our study of this essay, let's go back to page 461 real quickly and in 2b. Make sure you have this written down. We are studying, again at 2b, our expository essay. To expose means simply to show. So if you are writing, for example, when I ask you, as I will, when I ask you to write an expository essay, don't get freaked out by that. All that means is you're basically reporting some information. Telling me how you pop popcorn is an expository essay. Do you got me? Anything that involves processes. First you do this, then you do this, then you do this. That's all expository writing as well. Diction matters, the way word choice happens. We're going to see this in our study of longitude, as well as the tone or the writer's attitude towards subject, okay? We again have our chart there. We already used that chart for our study of the spider and the wasp. And now we'll turn to Dava Sobel's text, Longitude. Reminding you on 472, you want to study those vocab words so you're ready for our assessment. Hey, let's learn a little bit about Dava Sobel, born 1947. A child in the Bronx, New York, Sobel enjoyed trips on her family's sailboat navigated by one of her parents. Years later, she would transform a chapter of navigation history into her first bestseller, Longitude. Sobel attended the Bronx High School of Science, went on to become an award-winning science reporter for the New York Times and various magazines. Let's write this down. We saw this in our freshman year of study as well. How many of our authors spent time in journalism? Here's a classic example for one of the world's most important newspapers, the New York Times. She was a writer. In November of 1993, she attended a conference about navigation. She became fascinated by the historic contributions of clockmaker John Harrison. I would just write this down. Here, Sobel is a classic example of what I was talking about in my prior lecture, about learning to be curious. Reminding yourselves that when you were a child, you were curious about everything. If you spend any time around children, you know they're always asking why. Why? Somewhere along the way, we stopped asking why, which to me is kind of tragic. And so here, Sobel, classic example, goes to this conference, learns a little bit about John Harrison, the clockmaker. While researching the history of longitude, Sobel stumbled onto the topic of her next book, Italian Renaissance astronomer Galileo and his daughter. She wrote about their relationship in Galileo's Daughter, a very famous book. While researching longitude, Sobel traveled to London for research and to stand directly on the prime meridian. We're going to learn more about that in a second. Background for this essay: navigation is the science of finding the position and direction of a craft such as a ship or a plane. You want to write that down at level 1. It's going to be about navigation. Since ancient times, map makers, sailors have used a system of imaginary lines, longitude and latitude, to identify positions on the Earth's surface. Write down at 3A really quickly before we get into this. One of the books that I often will recommend to high school students and college students to read that can kind of reignite the whole idea of curiosity and wonder about the world is a book written by the great Daniel Bornstein, is his name. Bornstein. And he wrote a really incredible book called The Discoverers. And I highly recommend it to you. In that first part of Daniel Bornstein's telling of world history, it reads like a novel. He tells about the amazing thing that happened when humans started messing around with trying to somehow control time through clockmaking, and then of course the more important element of travel that came along with all of that. All right, let's turn now to page 474, 475. And we're going to mess around now with Sobel's a passage from Longitude. A brief history of her own fascination with parallels and meridians. To open the discussion, just helping you now at level 1, the challenge, to open her discussion of the challenge presented by longitude, she points out a key distinction between parallels and meridians. While the laws of nature set latitude, longitude would shift, at least until the prime meridian was fixed outside of London and Harrison invented his clocks. Sobel's comprehensive survey of the quest for a solution to the problem of longitude emphasizes the significance of Harrison's achievements. So we're going to have several things happening in this essay. Now again, it all comes back to attitude. If you want to say, this is silly, boring stuff, why do I got to learn about this? Then your reading of this essay is going to be a struggle for you. On the other hand, if you use the example of what we just finished with our study of spiders and wasps, if you use that as an example, maybe you go, you know, before I write off something like this being boring, I'm maybe going to ask a simple question. What can I know? Go back really quickly just one page to the top of page 472. Our big question for Unit 3 is what? What kind of knowledge changes our lives? Which is a really fascinating question. See, hey, watch this. As sophomores, we actually start to begin to ask this question now more seriously. What are you going to do in 48 months? Think about that. Because in 48 months, you're starting to get ready to think about graduating. And the question that people, my seniors, hate this question because it's always being asked of them. What are you going to do when you graduate? Like, what are you going to do? What do you mean what am I going to do? I'm going to like graduate. No. Like, what are you going to do? And hidden behind that question is the whole real question of what are your interests so that you can start to think about a possible job where you're interested in stuff. All of a sudden, we start to think more seriously in our sophomore year about the possibilities of what's coming. So we look at essays, for example, like this one. One more thing we might find ourselves interested in. You never know what will happen for you that will change your world, the knowledge that could change your world. All right, I'm with you on page 475. Let's just now enjoy the reading. We'll start to pay attention, of course, to the organization, no doubt, of how this thing's put together, just like we did with the spider and the wasp essay.
From Longitude by Dava Sobel. Once on a Wednesday excursion when I was a little girl, my father bought me a beaded wire ball that I loved. At a touch, I could collapse the toy into a flat coil between my palms or pop it open to make a hollow sphere. Rounded out, it resembled a tiny Earth because its hinged wires traced the same pattern of intersecting circles that I had seen on the globe in my schoolroom. The thin black lines of latitude and longitude.
476.
The few colored beads slid along the wire paths haphazardly, like ships on the high seas. My father strode up Fifth Avenue to Rockefeller Center with me on his shoulders, and we stopped to stare at the statue of Atlas, carrying heaven and earth on his.
It's at the bottom of 476.
The bronze orb that Atlas held aloft, like the wire toy in my hands, was a see-through world, defined by imaginary lines. The equator, the ecliptic, the Tropic of Cancer, the Tropic of Capricorn, the Arctic Circle, the prime meridian. Even then, I could recognize in the graph paper grid imposed on the globe a powerful symbol of all the real lands and waters on the planet. Today, the latitude and longitude lines govern with more authority than I could have imagined 40-odd years ago, for they stay fixed as the world changes its configuration underneath them, with continents adrift across a widening sea and national boundaries repeatedly redrawn by war or peace. As a child, I learned the trick for remembering the difference between latitude and longitude. The latitude lines, the parallels, really do stay parallel to each other as they girdle the globe from the equator to the poles in a series of shrinking concentric rings. The meridians of longitude go the other way. They loop from the North Pole to the south and back again in great circles of the same size, so they all converge at the ends of the Earth.
All right, let's pause for a second. Write it down at level 1. Notice that we begin with just a little reflection back to a memory when she was a little girl. So let's start there at level 1. She remembers being given this little toy, right? And then she remembers that her father took her in New York City to this place where, outside of Rockefeller Center, some of you will want to travel someday to see New York City. And when you go, you'll go to Rockefeller Center and you'll maybe get a chance to see this very statue. By the way, you've got a picture of it on 476 at the bottom of the page. Atlas, of course, in mythology is the one that holds up the world on his shoulders, right? And she remembers as well her fascination with the idea of how these lines somehow, they're imaginary lines, they don't actually exist, but somehow they define the globe. Then She remembers as well, even as a child, the latitude and longitude lines, which she says, I'm reading now with you again on 476, govern with more authority than I could have imagined 40-odd years ago. They stay fixed, she says. As a child, she says she learned the trick of remembering the difference between latitude and longitude. Let's write both of them down on our notes at level 1, right? The latitude lines are the parallels. Really do stay parallel to each other as they girdle the globe from the equator to the poles in a series of shrinking concentric rings. They're the rings that go around. That's latitude. The meridians of longitude go the other way. They loop from the North Pole to the south and back again in great circles of the same size. So they all converge at the ends of the earth, right? Now, it's going to be significant that this is the setup for our study here. What is significant about these concepts that, of course, when we study in mathematics, we know always have something to do with our study of especially geometry and algebra, right? All right, let's keep going. Pay attention now to how she talks about both of these as significant.
Lines of latitude and longitude began crisscrossing our worldview in ancient times, at least 3 centuries before the birth of Christ. By AD 150, the cartographer and astronomer Ptolemy had plotted them on the 27 maps of his first world atlas. Also for this landmark volume, Ptolemy listed all the place names in an index in alphabetical order, with the latitude and longitude of each, as well as he could gauge them from travelers' reports. Ptolemy himself had only an armchair appreciation of the wider world. A common misconception of his day held that anyone living below the equator would melt into deformity from the horrible heat.
477.
The equator marked the 0-degree parallel of latitude for Ptolemy. He did not choose it arbitrarily, but took it on higher authority from his predecessors, who had derived it from nature while observing the motions of the heavenly bodies. The sun, moon, and planets pass almost directly overhead at the equator. Likewise, the Tropic of Cancer and the Tropic of Capricorn, 2 other famous parallels, assume their positions at the sun's command. They mark the northern and southern boundaries of the sun's apparent motion over the course of the year. Ptolemy was free, however, to lay his prime meridian, the 0-degree longitude line, wherever he liked. He chose to run it through the Fortunate Islands, now called the Canary and Madeira Islands, off the northwest coast of Africa. Later, mapmakers moved the prime meridian to the Azores and to the Cape Verde Islands, as well as to Rome, Copenhagen, Jerusalem, St. Petersburg, Pisa, Paris, and Philadelphia, among other places, before it settled down at last in London. As the world turns, any line drawn from pole to pole may serve as well as any other for a starting line of reference. The placement of the prime meridian is a purely political decision. Here lies the real hardcore difference between latitude and longitude, beyond the superficial difference in line direction that any child can see. The 0-degree parallel of latitude is fixed by the laws of nature, while the 0-degree meridian of longitude shifts like the sands of time. This difference makes finding latitude child's play and turns the determination of longitude, especially at sea, into an adult dilemma, one that stumped the wisest minds of the world for the better part of human history. Any sailor worth his salt can gauge his latitude well enough by the length of the day, or by the height of the sun, or known guide stars above the horizon. Christopher Columbus followed a straight path across the Atlantic when he sailed the parallel on his 1492 journey, and the technique would doubtless have carried him to the Indies had not the Americas intervened. The measurement of longitude meridians, in comparison, is tempered by time. To learn one's longitude at sea, one needs to know what time it is aboard ship, and also the time at the home port, or another place of known longitude at that very same moment.
478.
The 2 clock times enable the navigator to convert the hour difference into a geographical separation. Since the Earth takes 24 hours to complete one full revolution of 360 degrees, 1 hour marks 1/24th of a spin, or 15 degrees, and so each hour's time difference between the ship and the starting point marks a progress of 15 degrees of longitude to the east or west. Every day at sea, when the navigator resets his ship's clock to local noon when the sun reaches its highest point in the sky, and then consults the home port clock, every hour's discrepancy between them translates into another 15 degrees of longitude. Those same 15 degrees of longitude also correspond to a distance traveled. At the equator, where the girth of the Earth is greatest, 15 degrees stretch fully 1,000 miles. North or south of that line, however, the mileage value of each degree decreases. 1 degree of longitude equals 4 minutes of time the world over. But in terms of distance, 1 degree shrinks from 68 miles at the equator to virtually nothing at the poles. Precise knowledge of the hour in 2 different places at once, a longitude prerequisite so easily accessible today from any pair of cheap wristwatches, was utterly unattainable up to and including the era of pendulum clocks. On the deck of a rolling ship, such clocks would slow down or speed up or stop running altogether. Normal changes in temperature encountered en route from a cold country of origin to a tropical trade zone thinned or thickened a clock's lubricating oil and made its metal parts expand or contract with equally disastrous results. A rise or fall in barometric pressure or the subtle variations in the Earth's gravity from one latitude to another could also cause a clock to gain or lose time.
All right, let's pause for a moment. Write it down at level 1. Already we're paying attention to the organization of this essay. Notice how she begins. Hey, let me tell you about a memory that I had once when I was a child that already was beginning to ask me about this really interesting concept of how we divide the globe up into these 2 sets of lines. We got the ones that go around the Earth and the ones that go from the poles. Those ones that go around the Earth are standard and easy, the latitude. But the longitude thing, totally different concept. To do it at all, you have to have some concept of time. That is to say, the thing that you guys have a tendency to look over my shoulder at up on a wall, that notion of the clock and how much longer is he going on with one or more of his stupid lectures, that we take for granted today. But for a long time in the history of the world, you didn't have this technology, which, by the way, I'm finding fascinating. None of you wear watches anymore, because you all get your time through your phones. So, for example, you're always looking at your phone to find out what time it is, because, of course, that is exact, quote-unquote, exact time, right? In other words, no matter where you are, you can be in Whirling, you can be in Tokyo, that time on that technology is exact, and you like it to be very exact. For a long part of the history of the world, we didn't have that kind of technology. Here's our problem. Big deal. Now, it's a big deal once you're out in the middle of a body of water. If you've ever been on a body of water where you can't see land, and you do this and turn all the way around in the boat, you can't see anything but water, which begs the question, then how do you know what direction to go? Now some will say, well, the stars. Well, what do you do in the middle of the day when you can't see stars? How do you know where to go? And if you only have a certain amount of food on your boat and water, then it matters to you the direction that you're going. Big concern. By the way, take a look on 478. Some of the science connections information there with longitude, latitude. Notice you've got some information. The equator, the Tropic of Cancer, the Tropic of Capricorn, and the prime meridian. The 0 line for longitude. Notice they give you a little map there to give you a sense of it, right? And notice that the longitude, the prime meridian longitude, runs right through England. Do you see that in your little map there, okay? Now, what our author has done is she's kind of set us up. She's given us a little bit of history, starting with Ptolemy, and now she's going to begin to talk about the invention of a clock. See, here's your problem. If you have a clock that pendulum swings back and forth, that works fine on land. It doesn't work on a boat for any number of reasons, not least of which the boat moves up and down. So, how are you going to tell time when you don't have a clock that will give you time? That's the question that she resurrects, and now we're ready to go to it, right? Let's pay attention now. See how well we can learn from this information.
For lack of a practical method of determining longitude, every great captain in the age of exploration became lost at sea,
479.
despite the best available charts and compasses. From Vasco da Gama to Vasco Núñez de Balboa, from Ferdinand Magellan to Sir Francis Drake,
Great
they
explorers.
all got where they were going willy-nilly, by forces attributed to good luck or the grace of God. As more and more sailing vessels set out to conquer or explore new territories, to wage war, or to ferry gold and commodities between foreign lands, the wealth of nations floated upon the oceans. And still no ship owned a reliable means for establishing her whereabouts. In consequence, untold numbers of sailors died when their destinations suddenly loomed out of the sea and took them by surprise. In a single such accident on October 22, 1707, at the Scilly Isles near the southwestern tip of England, 4 homebound British warships ran aground and nearly 2,000 men lost their lives.
Tragic, right? 480.
The active quest for a solution to the problem of longitude persisted over 4 centuries and across the whole continent of Europe. Most crowned heads of state eventually played a part in the longitude story, notably King George III of England and King Louis XIV of France. Seafaring men such as Captain William Bligh of the Bounty and the great circumnavigator Captain James Cook, who made 3 long voyages of exploration and experimentation before his violent death in Hawaii, took the more promising methods to sea to test their accuracy and practicability. Renowned astronomers approached the longitude challenge by appealing to the clockwork universe. Galileo Galilei, Jean-Dominique Cassini, Christian Huygens,
Important
Sir
scientists,
Isaac
right?
Newton, and Edmund Halley, of comet fame, all entreated the moon and stars for help. Palatial observers